I'm going to go over a few word problems that have to do with rational equations. So the first one I have, the variable C represents the concentration of a drug T hours after injection. So the first question I have is to find the horizontal asymptote of C of T. So I'm actually going to make this problem a little bit easier on myself, I'm going to say that y is going to be my CT, and I'm going to rewrite my t as an x. So I think it'll make it easier to look at. So then now I'm going to have the equation y equals x over 2x squared plus 1. You don't have to do that step, but it sometimes makes things a little bit nicer. So my first question is the horizontal asymptote. In this case, the numerator degree is less than the denominator degree. So I actually have a horizontal asymptote at y equals 0. So they don't just ask for the horizontal asymptote, they ask what happens to the concentration of the drug as t increases. Our horizontal asymptote is going to tell us the end behavior, meaning what's going to happen in a long time. So as t increases, or my x increases, my y value is going to get really close to 0. So then the second question asks to use a graphing utility to graph c equals c of t. You don't really need to know that notation, c equals c of t. Basically, you're just looking for the graph of the function. And you can try to do it on your graphing calculator if you want, if you have one. For now, though, I'm happy if you want to use Desmos. I think Desmos is really good for this type of thing. I'd like you to try it on your own, please, just see if you can get the correct picture. So pause the video, give it a try. And when I graphed it, I used Desmos, and this is the graph that I got. You might notice that mine looks a little bit different from yours. The reason for that is because I zoomed in a little bit. You're welcome to do the same. The other thing that I did was I clicked on, I wanted to do part 2 at the same time. It asked you, or part C at the same time. They asked you to determine the time at which the concentration is highest. So what I did was I looked at my graph to figure out where the maximum point was. And you can see that I clicked on the graph. If you click on the graph, actually, on Desmos, it'll automatically appear. And then you'll see those points appearing. And when you do that, you can just click on the point, and it will actually tell you the values. So the point that I got was, it was 0.707 and 0.3536. Remember that my x value is my time, my y value is my concentration. In C, they're looking for the time, so they're looking for the x value. So in this case, it is going to be 0.707 hours, you can even say after injection. So my next problem is quite a bit more challenging, but this type of thing actually is really common in calculus. So I thought it'd be important if for us to go over it together. The first thing they ask you to do is, first of all, they're telling you about UPS, by the way, is called United Parcel Service, in case you didn't realize this. So UPS has contracted you to design a closed box with a square base that has a volume of 10,000 cubic inches. The first question they ask you to do is to express the surface area of the box as a function of x. So we don't know the surface area, we do know the volume. So what I'm going to do, they're looking for you, by the way, to write something as like S of x equals something with x's. That's what they're looking for. You might be able to figure out what it is with x's and y's. In fact, I'm going to go ahead and show you what it is, but you actually need only x's. So the first thing, in order to find the surface area, is the bottom and the top of the box are both going to have an area of x times x. So it's going to be x squared for each of them. Since there are two sides that have that, I'm going to say 2x squared. Then each side is not a square. It actually is a rectangle that may or may not be a square. It has a base of x. It has a height of y. So each side has an area of x times y. Since there are 7 sides, it's going to be 4xy. So my overall equation for surface area is 2x squared plus 4xy. Now, remember what I said about a function of x? That means we have only x's in our function. We have no y's. So we need to figure out how to get rid of that y. And we also have one other piece of information that's really nice, is that volume of 10,000 cubic inches. So the next thing you're going to want to do is figure out an expression that has x equals something with, or y equals something with x in it. So you want to get y as a function of x. So I'm going to show you what we can do. So we know that the volume of this rectangular prism is going to be x times x, that's my base, times the height, which is y, or you can think of it as x squared y. We also know that our volume is equal to 10,000 cubic inches. So we know that 10,000 equals x squared times y. My final thing that I can do that's going to be really helpful is I can rewrite this as y equals 10,000 divided by x squared. So I'm still not done, by the way. They didn't ask me to find out what is y going to be equal to. They didn't ask me to find out what the volume function is. They asked me to express the surface area of the box as a function of x. So I'm almost done though. So I'm going to start, I have s of x. By the way, if you just write s with no x, that's fine. That's going to be equal to 2x squared plus 4x. The big difference right now is I'm going to substitute this expression I have for y in for that equation. So this is my final equation. You can keep it like that, or if you want to simplify it, you also are welcome to simplify it. If you do that, this stuff on the left-hand side ends up being 40,000 over x. So then for part B, they ask you to use a graphing utility to graph that function. Again, I think using Desmos is probably the easiest way to do it. So go ahead and pause the video and graph that s. Oh, and by the way, I recommend that when you put it in, you don't actually write the s of x, or you don't write s. You can if you want, but I think it's easier if you just write 2x squared plus 4,000x and put that into Desmos, or put that into the y equals of your calculator. So if you graph this on Desmos, you probably noticed that you maybe didn't see anything unless you zoomed way, way, way out. So I'm going to show you what my graph looks like, and I'll tell you a little bit how you can actually get that graph. So my graph looks like this, and it's pretty good actually, because I could see most of the features of the graph that I need. So I will tell you what I did. In Desmos, if you look on the right-hand side, there is a little wrench button, and under the wrench button, they have a minimum x and maximum x and minimum y and maximum y that you can put in. I think it has like inequality signs in between. So you're going to want to use that. I noticed that we knew the volume of the box was about 10,000 cubic inches. So I started off with my y values as being negative 10,000 to positive 10,000. And that one was pretty good. It worked out very well when I did that. But my x values, I only did from negative 100 to 100. Oftentimes, if you see a problem like this and you're trying to graph it, you just have to play around with the numbers and see what gives you the best picture. Now, if you tried it on your graphing calculator, there should be a button that says window at the top of your your keypad. It's right underneath the screen. And that will give you the same thing. You're going to use your X max and X min as negative 100 to 100, and your Y max and Y min from, as 10,000 and negative 10,000. So the next thing they ask you is for part C. They ask you what is the minimum amount of cardboard that can be used to construct the box, and D, they actually ask you what are the dimensions of the box that minimize the surface area. So our minimum value is going to be this point right here. And if you do the same thing as in the previous slide on Desmos, if you actually click on the graph, it will give you all of the most important points, including the minimum and maximum points. So this is the point that I get when I get the minimum point. By the way, if you are trying to do this on your graphing calculator and you want to know how to find that minimum point, just let me know in class time. I'm happy to tell you what to do that. I'm not sure how many people are using a calculator versus Desmos. So that's my minimum point. Now, this point, remember that my X value is the same as that X at the bottom, at like the side length of my base. This Y is my surface area. That's equal to S. So the minimum amount of cardboard is actually going to be the surface area. So the minimum amount of cardboard that I would use would be 2,784.953, and remember, it's in cubic inches. For part D, they ask you, what are the dimensions of the box that minimize the surface area? So the dimensions of the box, I know that my X value for my dimensions are 21.54. That's from this thing right here. And that's actually in inches. My Y value, I can figure out by using this equation right here. So I get Y equals 10,000 over the 21.54 squared. And if you do that, believe it or not, you're going to get 21.54. So actually, the minimum surface area, and you're going to find that this is true in many cases where you're finding minimums, minimum surface area is going to be if your box is a cube. So these are not dimensions, by the way. This is not how you write out your dimensions. If you want to write out your dimensions, you're going to have to write it as 21.54 inches. So that's my first side. My second side is 21.54 inches. And then my height is also 21.54 inches. So that would be how you would answer that question. Part E, by the way, asks you, why might UPS be interested in designing a box that minimizes surface area? You might be able to guess that UPS is a business, so their goal is to minimize the amount of money that they have to spend as much as possible. So the reason they might be interested in that is because it's cheaper.